Hello and welcome to a new video. Today I want to build a bridge between mathematics and programming, and that bridge I would say is functional programming. What is functional programming? Functional programming, in a sense, is just building functions with the help of expressions and composing these functions. You compose functions to new functions, these compose other functions, and so on. You really don't need many building blocks for functional programming. If you've seen one of the last videos I've done, what you actually need for an imperative style program, it's also very few building blocks you need. For functional programming, you need basically even less. What you need would be an expression, a function, and functions and appliance of functions, and that's basically it. I think it's called mu recursivity. Not quite 100% sure. You would have to look it up in your theoretical computer science book. But look at this. These are very interesting topics. It's basically you can see probably you know already that um, the, sh- the that you with you can build any algorithm with a while program, and you can build any algorithm with these building blocks I just mentioned for functional programming, and they are also very few. So once we know that the rest is basically just, something that is only helping us, or in a sense, some kind of syntactic sugar, we know everything we need, and yeah, it's very uh, good to know what the limits of the language is, or what we at least need to have, and from there we can, from this starting point, we can understand better how algorithms work, or how we can build algorithms in languages. So, enough talk. Let's go into the action. So we know that we can, yeah, we let's do everything we need for functional programming. That's defining variables. In the language I chose for functional programming is Clojure. It's a Lisp dialect, very easy syntax. I think I've never seen any easier syntax. Maybe there are some languages that have easier syntax, but this is really nice. Some might complain about the brackets, but I really love this language. It's so beautiful. You are lucky to get in touch with it now, except you have already. So either you were lucky before or you're lucky now. Unfortunately, the industry hasn't adapted to this language yet, so I don't know why, but maybe we will be stuck with other languages for some time before this beautiful language is getting more prevalent. Anyhow, as long as it is not, we are going to learn it and build some nice programs with it, since this is the whole fun, and we are also at the same time applying our mathematical brain to things or processes, and that's what combines mathematics with programming. And let's do it. Okay, so let's define some variables here. I have also a Jupyter Notebook installed here just with Clojure. So this is how you define variables. as you can see here, I define the a as variables. It's now 3. Let's check what type is it. It's, you can see here it's dynamically typed language. So that's why I'm checking for the type. There are ways to go around this and to have some kind of type checking, but let's for now stick with the basics and or repeat the basics. So this is how you define an integer. Let's define, not type, but let's define a string. This is hello world. So this is string. Don't distract yourself by this user here. Let's just ignore it for now. It's called a namespace, but let's not get distracted by that. So let's evaluate b. As we can see, nice header. It's saying hello world. So printing it out will be println, always with the brackets. And as you can see, we have already the variables, the expressions, the 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 appliance of a function, which was here. By the way, this is the nil sign. It's like none, similar to none in Python or null in Java. Here we have applied the function, and yeah, let's now define the function, and we would be ready for Turing complete programming. So let's define a function that we call my function, and let's take a parameter. It's looking like that, and now let's return the parameter. That will be just doing that. So simple function, evaluate it. So let's call that function. What would we expect? We would expect that this will return whatever we put in there. Yeah, and that's exactly what's happening. So let's start with some arithmetics. It's in Clojure infix notation, so the plus sign is the first one, the first we have to do if we want to do plus, for example. Arithmetic 3 would be 6, so let's apply it, and yeah, it's working. Nice. So let's move on, and let's define now a function that adds 1. Let's call it add1. It's taking a parameter a again, and we are adding 1 to it. So add 1, the function defined, so let's apply it. We call the function name and put in 1 as parameter. We would expect 2. So yeah, that's also working. Very nice. So this is basically what you need: defining variables, expressions, and functions, and applying the function. Yeah. So let's move on with some higher level stuff. In Clojure, there are the main data structures are lists, vectors, maps, and sets. So very simple. Lists look like this with brackets. You see here the apostrophe here in front. Otherwise, Clojure would think this is a function applying the function, like here it would apply the 1 as a function. So this is why the apostrophe is here. It's saying, I'm saying with this that this here shouldn't be applied like a function appliance, but it should be taken as a list. So we can do type and check the type, and as you can see, this will be a list here. So very nice. This is how a list looks like. We can also define a vector like this, and we can define a map with this syntax here. So for example, the keywords are actually done with a colon in a map. So let's say hey, ho, hi, hi, or hey too. Okay, not very creative, but it will do. So now we have created a map. So let's define the map and bind it to an identifier. So let's call it our map, and I will copy this map here. Like that. So now we have a map, and now we can say we want to get from our map the hey. So now we would expect ho. Yep. Hey ho. And if we say get hi, oh man, this map is not a good map. This is not a good map. Anyhow, you get okay, now I distracted myself a bit, but this is not a good map. Let's see. Yeah. So now it's showing, and it's working quite well. So as you can see, simple data structure. The difference between a list and a vector is a vector you can say it's like an array basically. So you can say I want this second element, and you couldn't say this in a list directly. So let's just prove that. Let's define the way to get 1, 2, 3 like that. This element, and let's check. Hope it works. Yep, nice. So let's try to do it with a list. Might also be working, but then there would be probably some kind of type conversion. Not sure. Let's just try it. Yeah, no, it's not working. Okay, nice. So what I said was true. So you can actually, in a vector, it's like an array. You can see this is the element 0, 1, 2, right? And in a list, there is nothing like that. You have just a simple plain list. There's no indexing of the list. Okay. So I will leave the set out of this, but the set is defined very similar to the map, just with a route in front of it. So these are basically the most important data structures. What I now also want to show you are filter map and reduce, because you see it also in other languages and it's very prevalent in functional programming. So I want to introduce this here as well and show you what these functions are about, because they take other function as parameters, and that's a good thing to grasp. So let's start with map. So what does map actually do? Map takes a function with one parameter, it applies the element from the list you also give it, or it's called a collection. Collection is just a list is a collection is just some kind of I would say an abstraction of data structures like lists, like vectors, like mapped is basically a collection of the data structures. So, but the only thing is saying that you can put in different data structures into a map. And let's yeah. So map needs a function. And what function do we have? We already have the add one function that takes one parameter and returns something. And that something will be in a new list. So it takes first element, applies that function, puts it in a new list as a first element, then applies this element, it applies this parameter to this function and puts it as another element and then the next one. So this will return a new list, or it's called a new other type. It's called here sequence, but that doesn't really matter. So when we do this and we apply map, we apply the function that we give here as parameter to each of this element. So what we will get returned is, okay, what is 1 plus 1? It's 2. So 2 and 3 and 4. So it will return us basically a data structure that has 2, 3, and 4. And that's what happened. So map is basically iterating over this data structure and applying this function. That's all as map is doing. And after the applying this function, adding putting it in a new data structure and returning it. That's everything map does. As you can see, it's independent of these elements here. There's nothing that's taken over to the next one or so. It's just independence. Whether here is 5 or 1,000, it doesn't really matter. It will not change the result of the other two, right? It will just change the result for this element, for the first element, that will be 11. Okay, nice. So map, pretty easy to understand with this example, but of course, like with every case, you just will have to do a lot of examples like that to grasp it maybe a bit more, or you're smart and grasp it directly. I am not, so I need more exercises. But that's good. And yeah, so this is map, very easy, once you get it. So what is filter about? Filter is also that takes two parameters, is a function that takes two parameters. It's taking a function as first parameter, and it's taking, again, a data structure or a collection for that matter. We will give it a list again. But now the difference is the function you will put in here is a function that is taking also this one. It will evaluate this function to true or false, and whether it's true or false, it will create a new list with it. So if it's true, it will stay in the new list or new sequence, and if it's false, it will not be in the new list. So that's very easy. So let's make an example. I will first need to define a function for that. So let's define a function. We call it our comparison. Our comparison. We have a parameter. We call it a again. And we say like that. Here we say 1 is smaller than a. So a is bigger than 1. Then it's true. So if it's true, it's gonna stay in the list. So everything bigger than 1 will be filtered, will be in the list, and everything smaller equals 1 will stay in the list. Will be taken out of the list. Sorry, not stay in the list. So let's try it. Let's use it. Filter. Our comparison is the function we give as parameter, and then let's do it and put in a list. So let's think about this. So what will we expect? So 1 will be put into the function. 1 is 1 smaller than 1? No, it's not. Okay, let's put in 0 also to make it clearer. So is 1 smaller than 0? No, it's not. So it will be false, so 0 will not be in the list anymore. 1 smaller than 1? No, of course not, so it will also not be in the list. So is 1 smaller than 2? Yes, it is. So it will be in the new list, and 3 will be also in the new list. So with this, we are just filtering out everything that is smaller equals 1. So let's do it, and yeah, works perfectly. So this is how filter works. Very, very easy. There's also you can also, instead of define the function here, you can define the function inline, but let's leave this to maybe another session. So that's filter. As you can see, also filter is very similar to map, but map is applying something and creating then for each element something, but filter is applying also a function, but not but after it's false or true, it's checking whether the new element, the new list will have this element in the list or not, depending on the outcome of the function. So this takes, so filter takes a function that has one parameter and is returning true or false. So then last function I want to discuss for today is reduce. Reduce is a bit different. It also takes a function though, and a collection. We'll put in here a list again. And the function takes 2 parameters, and it also, the 2 parameters need to be, it takes 2 parameters, and the function also needs to have needs to map into the same space basically where this can be, the function can be applied with the next element. Sounds a bit tricky maybe, but once you see it, it's easy. So we can do plus for that, because plus is having exactly that requirement. Plus is taking 2 parameters, and plus returns also a number again, and that number we can use to add the next element with that number and add the next element with that number. So basically what's happening is taking first 2 elements, putting them into that function, applying it, will be 3, right? So we have then 3, and 3 will be applied with that 3. So we have 3 plus 3, it's 6. So 6 is what we get returned, and it will be then applied with the next element, which is 4, and then it's 10. So the whole result will be 10, if I would not have forgotten a bracket. So yeah, as you can see, this is how reduce works. Reduce, the difference with reduce, it's basically also some kind of iteration, but the end result is very much depending on what comes before. So it's not like for each element. So if I put in here, of course, a 2, then the whole result will change. So this is different to filter, because filter will be independent of whatever is in the list, um, and map as well, but reduce is very much, the result of reduce is very much depending and affecting basically, or gets affected by the list, by all of the results, by all of the elements in the list, sorry. Yeah. So reduce is can do much more than that, but I think this is a good example for beginners. Of course, you should also try to experiment with it. Maybe let's just create another reduce function where we do something else. So let's define a function that that concatenates strings. So we have two parameters. Just to make it a bit clearer, I just want to introduce it here for now. But so we have two parameters, and what this does is just concatenates these two. So, but we can try it. So concat string, basically, hello there. Takes, of course, two parameters, so this will not work, but let's do that. Hello there. And as you can see, it concatenates. So what we can do with reduce now, we can say what by the with what string would also do if I do it with string, but for the sake of this example, let's put in this function concat string, and put in here a vector with hello there, how are you? So now let's think about this again. So what should happen? It's taking these two elements at first, putting it into that functions, and then we get hello there written. So, and after that it concatenates the result from that, hello there, with how. So, and after that with R, so it should result in a long string. So we have basically have put this vector into a new string that has showing hello there, how are you? So let's try it. This worked fine. Maybe this example is also something that helps to understand how reduce work. So yeah, that's basically what I wanted to show with Clojure. I think and I hope I can do more like this, but let's see how what the future will bring. So thank you for staying with me, and see you next time.